In section 4.6, we're going to take about what we've learned this chapter about proving triangles congruent and add one more step. And that step is called CPCTC. So CPCTC is an abbreviation. It's an abbreviation for the phrase, corresponding parts of congruent triangles are congruent. It can be used as a justification in a proof after you have proven two triangles congruent. So let me break this down for you so you understand what we're doing. So I have drawn two triangles. Now, in this problem, I'm not telling you they're congruent. However, what I have done is this. If they are congruent, then here are the 6 sets of congruent parts. 3 sets of angles, 3 sets of segments or sides. Now in this problem, it is congruent. And the reason is because A and E would be right angles, so that would be angles that are congruent. Segment AC and EC are congruent, and 1 and 2 are congruent because of vertical angles. So because A and E are congruent, 1 and 2 are congruent, and AC and EC are congruent, in that order we have angle, side, angle. So we already know these angles are congruent, and this set of segments are congruent. But because of CPCTC, once you have proven triangles congruent, I can now state that all of the remaining pieces that are congruent, all the remaining pieces that I have not proven congruent, are now congruent. So because the red ones we proved congruent, or they were congruent in the given, the blue ones are also congruent because the triangles are congruent. And the reason is because of CPCTC. So let's do an example. To design a bridge, you need to find the distance from A to B. Locate point CDE as shown in the figure. If ED is 600, what is AB? Now, this is just like the problem I gave you. The first thing we have to do is in order for these two to be the same. So what we're going to determine is this side is 600 feet. AB should also be 600 feet, but only if we know the triangles are congruent. So because we have right angles, there's an angle. Because each of these sides are 500, we have segments. And because we know vertical angles are congruent, we have these two angles. So we have two angles and their inclusive side. So we can say that these two triangles are congruent. And because of CPCTC, we know that the length of AB is also 600 feet. So example number 2. Let's do a proof. Proving corresponding parts congruent. So we have in our given that segment AB and segment DC are congruent, which have already been marked in the picture. We also know that angle ABC is congruent to angle DBC, and we want to prove angle A and angle D are congruent. So the first thing I'm going to do is separate my overlapping triangles. So I've already written down the given. So as you can see, we already have angle A or side AB and segment DC and two angles. So we need to have either another angle or another side. Well, looking at the picture, we can say that segment BC is congruent to itself because of reflexive property. So now we have all of our pieces that we need to prove two triangles congruent. So we can say triangle ABC is congruent to triangle DCB. And the reason for that would be side, angle, side. And then the last step is proving what we want, which is corresponding parts of congruent triangles, CPCTC. And from there, since corresponding parts of congruent triangles are congruent, I can say that angle A is congruent to angle D. Example number 3. Given that we know segments EG and DF are parallel and congruent, I want you to prove that ED and GF, those segments, are also parallel. So let's start our proof. Now let's try to develop a plan. Remember, in order to prove lines parallel, we either have to have a transversal with perpendicular lines, which we don't have, or we can prove angles congruent, which we do have those. So if I'm looking at ED and EF parallel, I have a transversal between them, which is segment GD. I can prove the alternate interior angles congruent in order to prove them parallel. So my goal is to prove that angle here and this angle here congruent. So let's prove these triangles congruent first. So I have a side, that's all I have. And once again, if you would like to put an S next to the sides we're talking about, you can do that. I also know that segment GD is congruent to segment GD because of the reflexive property. That's also a side. What else could I do here? Well, I know from my given that EG and DF are parallel, which means I have alternate interior angles here. So I can say those two angles, which are angles EGD and angle FDG, are congruent because of the alternate interior angles theorem. Step 4, they're now congruent. I have an angle, a side, and another angle. So I can say triangle GED is congruent to triangle DFG because of side, angle, side. Now remember, I'm proving segments parallel, not congruent. So we can't use CPCTC to prove parallel lines, but we can use CPCTC to prove that angles FGD and angles EDG are congruent because of CPCTC. Now, one more step. I can say segment ED is now parallel to segment GF. Why? Because of the converse of the alternate interior angles theorem. Our last example, using CPCTC in a coordinate plane. Now, I'm not going to actually do a proof on this one because we're actually going to do math with it. So I'm not going to do a 2-column proof. But I still have to use words to prove what I'm doing. So in this problem, we're given 6 points. Now, they're already graphed for you. You want to prove that these triangles are congruent. You could prove angles, but there's no way to really prove angles congruent in a coordinate plane. But we can prove the sides congruent. So what we're going to have to do is find the length of all 6 sides of each triangle using the distance formula. The square root of x2 minus x1 squared plus y2 minus y1 squared. Now I have all the work written here, but AB, we subtract 5 minus 2, get 3. 3 squared is 9. Negative 1 minus 3 is negative 4 squared, which is 16. And we can go through and see all the sides. So you can notice, or you will notice, that all of the sides are congruent. So we can say by side, 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 triangle ABC is congruent to triangle DEF. Now, the last thing we have to prove is that the angles are congruent. So therefore, angle ABC is congruent to angle DEF because of CPCTC.